Hello, good day, everyone. I welcome you all to this online tutorial. So I would like you to share the information across to other students, share the information across to other students on the group. Let them have this information. So it's very, very important at this moment. If you are watching, please let everybody knows on the group that we are now live on YouTube. You can join our YouTube channels. Pass the information across to each and every one of them. I can see someone is just joining us, not quite long. Yes, keep calling others so that they can be here. Let's start what we are here for. Exactly. Okay, that is it. Let's start what we are here for. I am still waiting for others. They should join this live class in connection to what the call measurement of its capacity. That is measurement of heat energy. The measurement of heat energy with respect to um, what we call specific heat capacity, where heat, the heat energy, where the heat energy given there is equal to the mass times specific heat capacity times what we call the change in temperature or the temperature. That is what we have there. And so this arrangement that we have in this place can be written in form of H equals to MC theta. Or we have H equals to MC change in theta. That is what individual represents. So exactly. So I would like you to go to the group, inform everybody. It seems to be everybody is not online, as you can see from there. Yes, let's watch it out. So if the heat energy equals to MC change, what's called the mass times specific heat capacity times the temperature, then from what we have there, we can also say that C equals to, that is specific heat capacity equals to H over what we call the change in theta. Take note of that. Change in theta or theta directly. Now, the expression here is when you need to calculate the specific heat capacity. But there is something I want to add to this in addition to what we have here. This formula that we are seeing in this place is equivalent to, if you are using electric source, that is, the energy is coming from electric energy, then H equals to IVT, where the I represents the current, V represents the voltage, that is potential difference, and the T represents what we call time in seconds. Take note of that. The current in ampere, the potential difference, which is the volt that is there. So then we write C equals to H over m theta, when H equals to IVT. So we are going to have C equals to IVT over m theta. Each and every one of them still remain constant there in the expression, as you can see. So this expression that we have here is what we use to calculate things connected to 8, as you can see. Okay, so now from this expression that we have on the board, a series of calculation you can be asked to perform on it. But before I go into that, let's first of all talk about this. Where heat is measured in what we call joules with respect to kilojoules, take note of that, kJ. Now, the M represents the mass in kilogram, the theta represents what we call temperature, the temperature which can be in what? In Kelvin or in theta. Okay. Now, you can find the value or the unit of what's called the specific heat capacity. So, for specific heat capacity C, we have C equals to kJ over the mass is kilogram. Then we have temperature for this. So we're going to have kilojoule followed by per kilogram followed by per Kelvin. Or you have kilojoule followed by per kilogram, then per degree Celsius, as you can see there. Each and one of them for specific heat capacity. So this arrangement that we are seeing in this place specify the unit that is being used for heat. It seems to be you have not informed others on the group that we have a class ongoing here. But irrespective, you can use your pen and be writing one or two things that you see on the board. And it should be noted that different substances, they have their own specific heat capacity. Exactly. They have their own specific heat capacity. So you have to know for each substance that you are actually dealing with. So what is specific heat capacity? Is the amount of heat required to raise the temperature of a substance per degree Kelvin. Okay, per degree Kelvin. So that is what it represents there. Now, having to look at that, let us look at what are other things that we need to solve there. So you only use this formula to solve a problem if the question demands for specific heat capacity. Take note of that. Also, this formula that is in this place, you only use it to solve a problem if you are looking for specific heat capacity. But there are a series of ways we can write this formula. It depends on what the question asks you to do. Take from this place now. When your H equals to IVT, okay? If you replace it in this equation, that means IVT equals to what? MC change in theta. I've said it earlier that the theta represents our temperature from this given equation that we have here on the board. So, whatever the question asks you to calculate, that is what we are going to calculate from it. So, that is that one there. Now, mass of a substance can be given, the heat required can be given, and all other related factors or parameters can be given. Yours is to look at the question carefully and know what is required of you. Then you have to do the needful there. Okay. So now, please, if you are following this class, I would like you to hit like. Okay. So when you hit like, I'll definitely know that you're actually following this class. Exactly. So that is that about that there. Okay. So now let's check some possible calculations that we may need to solve here. Don't forget all the formula I've given you on the board right now. They are definitely important in solving various related problems. Thank you very much. I can see you hit the like. Okay. Now let's go this way. So I'll be taking most of my questions from the past questions in order to navigate through a series of problems you can be asked to solve. So let me start from this side to make it easier. I've been taking your JAMB past questions. JAMB past questions. JAMB past questions. Okay. And let's start from ULA 92, question 17. So the question says how much heat is absorbed when a block of copper of mass 0.05 kg and specific heat capacity 390 joule per kilogram per Kelvin is heated from 20 degrees Celsius to 70 degrees Celsius. Now, let us solve this problem that we have on the board together. How do we solve the problem? How much heat is absorbed when a block of copper of mass 0.05 kilogram and specific heat capacity of 390 kilojoule per mole, okay? That's joule per kilogram per Kelvin is heated from 20 degrees Celsius. Now, from what's it called? 20 degrees Celsius to 70 degrees Celsius. Okay, so what do we have to do here? I don't know whether it's the network that is disrupting everybody, but I can see that some of us are going, are coming, are going, are coming. But irrespective of the case, I will keep on solving most of these related problems as seen on the board. Exactly. So in order to solve this problem, we analyze the formula that is needed to solve this problem and solve it straight. Okay. How much heat is absorbed? H equals to MC followed by a change in theta. Okay. H equals to mass 0.05 followed by specific heat capacity 390 times change in temperature from 70 to 20, subtract 0. Yes, 390 times, that will give you 50. Multiply everything that we have here through times 390 times 50. We give you 975. That's what we're going to have there. So 975, 1, 2. 9.75 times 10 raised to power 2. So times 10 raised to power 2, take note of that. Joules of heat is needed. That is what the question asks you to do there.